want me to talk about it?
If time permits, we'll check in again.
Okay, our current nav situation, they're working on a couple issues with their terminal, but otherwise everything is good. We are pretty much right on target, right where we need to be. So we've had a clean ride so far, and we'll come back to them later to see if anything has changed. In a couple of minutes, the EDL activity lead and I will brief the flight team on what to expect over the next hour or so, as we're just over 50 minutes from entry. So we'll talk about what activities are between here and EDL start, and then we'll also talk about what folks should expect to see data-wise throughout EDL.
Testbed flight.
Could we go to a local net?
Standby 1. Let's go to local 1.
Sounds good.
MSTD flight on level 1.
That's right.
Go for it.
And while I have a moment, I'd like to show you two visualizations we'll be using during our landing coverage. One of them is what we talked about just a little bit earlier. It's the Eyes on the Solar System, which is a computerized simulation using predicted data to illustrate mission activities. It gives you a sense of what things will look like from different vantage points, including the view from the spacecraft, from the surface, and more in real time. You can ride along with us to Gale Crater, in fact, using Eyes on the Solar System on your own computer by visiting eyes.nasa.gov. And then during entry, descent, and landing, we hope to have a real-time visualization, a simulation also based on telemetry from Curiosity via the Mars Odyssey orbiter. We have that display only if we have a communications link with Odyssey during landing. Even then, there may be data dropouts as Curiosity switches antennas during her different configurations. The screen will pause for just a short time with the last known state of the spacecraft, and you will also see the location and orientation of the vehicle and the velocity, altitude, and the amount of fuel on the descent stage on the dials that you see along the bottom, all reported in real time by the vehicle on its way to the surface. So there you have it. Two visualizations, one based on predicted information, and the other will only be available if we get that real-time telemetry from Odyssey. And one more time, let's go back to Alan, back in Mission Control.
The EDL activity lead right now is giving a briefing to the flight team on what to expect between now and through EDL. Shortly thereafter, I'll give a briefing to the team on what to expect from an EDL comm perspective, what kind of data we expect to see during EDL. So we can listen in right now to the activity lead.
This will result in the navigation filter not syncing to the cruise sensor data anymore, and the navigation filter will now propagate exclusively on the DMU until the TDS is powered on and running. UHF will be powered on but not transmitting at this point. Following that, at 10:09 local time, the HRS bent anchor will execute. Here, the BCBs will be placed in manual mode in preparation for firing pyros and for completing EDL, so the charge vets will be off and the discharge vets will be on. Pyro firing cards will be powered on and the pyro bus will be armed. Cruise stage devices will be powered off, and the flight software will stop talking to the cruise PAMs, all in preparation for cruise stage set. The first set of pyros that we'll fire at this time will be the HRS bent pyros, and that will happen at 10:11 local time, so approximately 2 minutes after starting that anchor. 2 minutes following that, at 10:13 local time, we'll begin our preparations for cruise stage separation, where the communication system will be configured for X-band tones. So the following actions will be reported by the EDL ops via tones, or we'll initiate the descent stage thermal batteries, again via pyros, open up the power dead phase relays between the cruise stage descent and the rover, fire the PV1 and 2 pyros that enable the descent stage prop system. Following that, we'll do cruise stage separation by executing the pyro sequence that performs that. And from that point on, EDL ops will take over.
Okay, copy. We'll be on tones. And EDL ops, let's hear commentary on what we can expect to see from that point forward.
Okay, I'm just going to go over what we'll expect to see in real time. We have other data from other sources after landing, but I'll just go with what we see right now.
That's fine.
At about 11.5 minutes before entry, which is about 1.5 minutes before cruise stage SEP, that's when we'll lose telemetry and switch to tones. All we'll have is tones for the next 13 minutes or so. There may be a brief interruption in those tones around cruise stage separation, as the cruise stage may block the transmission of those tones from the spacecraft. About a minute or two, minute and a half to 2 minutes or so past entry, we'll begin to pick up telemetry again through UHF, through Mars Odyssey. We should begin picking up that bent pipe first, kind of ratty. We'll get, I think, sporadic coverage at first as we cross the received power threshold. It's an 8 kilobit per second stream, but remember, there's only 500 bits per second allocated to EH&A, and most of that will go to prop and thermal. So don't expect to see too much on your consoles. The vast majority of the stream is committed to EDL-specific data, which you'll see pop up in the EDL telemetry visualization and in the EDL perspectives. Note that there are many expected outages. First, around acquisition when it's kind of ratty, then again around parachute deploy when we have high dynamic events. Also, we have times when we turn off the transmitter, times like backshell separation and rover separation, where we should expect to see outages. Odyssey requires a lock for us to have telemetry, so those outages may be prolonged until we relock up again. We will lose tones about 5 minutes after entry, somewhere around the time of heat shield separation or shortly thereafter. That occurs because Earth is setting from the spacecraft view. The relay UHF stream will continue all the way until touchdown plus 5 to 7 minutes or so. Remember, our touchdown time is variable by around plus or minus a minute, so the post-landing coverage time varies as well, and also depends a little bit on how close we are to the mound. The first replay of the EDL data collected by Odyssey will be around 0710 ERT. It shouldn't have any new content, but might be useful if there are any hiccups on the ground side during EDL.
Flight Telecom.
Okay, copy EDL com and Flight Telecom.
Yeah, Flight, we have reacquired. We've dropped a two-way, and we've reacquired in one-way.
Okay, copy one way, and that also is commensurate with the conclusion of our last EDL com window shortly before that. So we are no longer getting packetized data at this time. All right, and our next anchor is the EDL start anchor.
Don't mess around.
At 0444. So standing by for about 5 minutes for that anchor to commence. And subsystems will be...
We're about 45 minutes from entry. We're getting ready for the EDL start anchor in a few minutes. At that time, we'll enter what's called the EDL main mode, where the vehicle is going to do a whole bunch of things that will prepare us for EDL. Telecom has just confirmed that we've turned off the transmitter and that the vehicle is now sending back data in one way. So we're no longer two-way communications with Curiosity. So she's just talking to us. We're not talking to her anymore. We just conducted a couple of briefings to inform the flight team of what to expect over the next 45 minutes to an hour or so, both from what activities they'll see, what monitors will trip on their stations, kind of alarms that might go off that are expected, and then also what to expect from an EDL-COM perspective in terms of what data we will actually get back in real time. So the team is prepared. They've heard this briefing a couple times. We just want to make sure that everyone remembers.
All right, we are about about 40 minutes past the hour. We are less than an hour away from Curiosity's entry into the Martian atmosphere. That takes place at about 10:24 p.m. Pacific time. And what will that be like? Well, engineers here at JPL call it 7 minutes of terror, and here is why.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it will only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the Skycram maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage, it's in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
That video was released about 5 weeks ago and immediately went viral. On YouTube alone, it has had over 2 million downloads. The video lays out the many things that have to go right in order to land. And if one thing goes wrong, the whole mission might be lost. With us right now is Adam Stelzner. He is the lead for entry, descent, and landing. And one of the things that folks probably should be aware of are the innovations that came out of having to land such a large rover on Mars. And I thought this would be a good time to talk about them.
Great. Well, Gaia, there are two big things that we do in EDL that are sort of new for Mars. The first, when we're entering, this is a model of the entry capsule. When we enter the Martian atmosphere, usually we would have come in and just sort of hit the atmosphere squarely. But this time we have some extra weight on one side of the spacecraft, and that makes it fly at an angle of attack. And that angle of attack develops lift. And then we take that lift and we steer it back and forth, up and down, to steer our way through the atmosphere. What this allows us to do is it takes an uncertainty that we would have experienced in the landing footprint from hundreds of kilometers, at least 100 kilometers, and is able to shrink it down to 20 kilometers. This is something we need to do to land inside Gale Crater.
In that smaller ellipse.
In that smaller ellipse.
So you're able to slow yourself down. If the atmosphere is a certain way, you need to slow yourself down more or less.
That's right. If it had been a warm day, we might have a problem with flying too long. If it had been a cold day and the atmosphere were dense, we might slow down too fast and end up short. So this allows us to adjust for that atmospheric variation and adjust for variables at the entry point if we aren't navigated to the exact correct entry point.
All right. Innovation number 2.
Innovation number 2 is the sky crane. Everybody notices that. It looks a little bit unusual. The sky crane really is composed of 2 pieces. We've got the rover and the descent stage. And 20 meters above the surface, these two things separate, and the descent stage and the rover together, connected by cables not shown here, slowly make their way down until the weight of the rover is taken up by the Martian terrain. When that's happened, the descent stage recognizes that the rover is no longer being held by it, cuts itself free, and flies away to a safe distance.
And that's the way we want to see it later tonight.
Flying away to a safe distance and leaving Curiosity here with her wheels down on the surface, ready to begin her surface mission.
All right. Well, thanks for walking us through it. I know you are anxious to get back into that control room. So let's go back to Alan Chen right now.
Okay, we've just entered the EDL main mode. The vehicle's making irreversible preparations for EDL. There's no going back at this time. Cruise fault protection systems have been disabled. Those are the systems that kept us from doing things that we wouldn't want to do during cruise, things that wouldn't be safe. During EDL, we're about to do a whole lot of things that would be considered unsafe during cruise. It's also making some changes to the telecom system as well to prepare to send the EDL real-time data that we'd like to send. So far so good. Everything looks nominal. The flight director will conduct a short poll to assess the spacecraft readiness upon completion of the actions. It sounds like he might have already. I might have missed it.
We're going to do a subsystem poll.
Nope, we're going to walk through the subsystems to make sure that we're happy at the completion of transition to EDL main. So we'll listen in for that.
And activity lead flight, let's go ahead and record telemetry.
I'll read it off to you.
GDS flight.
Go ahead, flight.
Yeah, could you come have a look at the missions workstation, please?
Copy that.
at this time, the subsystems are taking a look at the data that's come down after these activities have been completed. They're just trying to make sure that everything's okay. Flight director will conduct a poll of all those subsystems to make sure that everything's going well. But so far, everything looks pretty good, and we'll check in very shortly with them.
Finally, suggestion was
Okay, flight EDL, if you're ready.
I'm ready.
Okay, so on step 715.6, the SCED time for the current anchor is 4:30:45.688. That was for previous.
I'm sorry, can you repeat that one more time?
226 is fine.
Copy. 04
Yellow to purple.
30 45
I think that's 226.
decimal 688.
Okay, copy that.
For step 715.8, the next anchor time is 04 52 45 decimal 700.
Copy.
And then we can verify EVRs from steps 715.10
This time, the activity lead is
through
verifying
715.34.
the actions that were completed during EDL main and going over when the next expected actions are.
We did verify command no op in our EDL 200 sequence, so that executed successfully. So that's step 715.36. And in step 715.38, our spacecraft mode is indeed EDL main.
Maybe able to see
Roger that.
the flight director, mission, and EDL activity lead checking off these steps and procedure. Just want to make sure that we get everything.
715.46, we did see all EDL devices marked healthy. For 715.47, we verified that we're in Windows disabled mode. And for 715.48, we verified that EVR.
Okay, copy. That confirms EDL start anchor activities are complete. Let's do a quick subsystem poll. Deltas only systems.
Flight systems changed to the spacecraft mode. It's now EDL main. The new CBM background ID is EDL reserve TWNC. In terms of changes to the hardware configuration, the backup REPA is powered on, and the cruise stage cap heads are now powered off, and otherwise systems is nominal.
Copy that. Power.
Flight power, significant changes on the power configuration. As mentioned by systems, REPA Bravo is now on. We saw an increase in current of about 300 milliamps for that. Cat bed heaters on the cruise stage have been turned off. Power subsystem is nominal otherwise.
Copy. Thermal.
Flight, this is thermal. The Marty heater has been turned off as expected for EDL main. The only other state change for thermal is that soak back from the DRCS cat beds into the valves continues. The temperature on the warmest DRCS valve is about 34°C, which is just a couple degrees above the max set points.
Okay, copy. Prop.
Flight, this is Prop. We are nominal on the descent stage and cruise stage propulsion systems. The only change across EDL start anchor is the turn off of B-side cat bed heaters as expected.
Roger. Avionics.
Flight avionics, there's no change in the avionics state, and we're still green across the board. Second Chance contingency software is now armed and ready to take over in the event of a prime computer reset.
Roger. Flight software.
Flight software is nominal. There is no change in flight software execution state across the EDL start anchor, and all flight software metrics are still per predict.
Copy. Fault.
Our only change is that all our system fault protection responses are now disabled.
Roger. Data management.
NTMX is nominal. The only change is we are now receiving only real-time data products.
227 OD.
Copy that. Telecom.
Telecom is nominal. The only change is the uplink transmitter has been turned off. Therefore, the uplink carrier lock is unlocked. We are in one-way non-coherent, and the coherency is disabled. And also, the ranging is disabled on the SDST.
Roger. ACS.
ACS remains unchanged over the last anchor, and currently Mars is 38 degrees field of view.
Getting very big in the window. EDL activity lead. Anything else to add?
Nothing else to add, Flight.
Copy. Mission.
Nothing else, Blake.
Okay, copy. That completes our post-anchor
Everything is good.
following
Post-transition to EL main, everything looks great.
EDL phase lead, I believe has something to say.
Thank you, Flight.
Okay.
Thank you, Flight. I'd just like to thank the cruise team for bringing us over 350 million miles, 2 unplanned nav filter parameter changes, and 1 heck of a lot of professionalism and dotting of the I's and crossing of the T's. Curiosity is in fantastic shape to perform entry, descent, and landing, and she's there because you guys got her here. So thank you very much, and good luck. See you on the other side on Mars.
Roger. Thank you, EDL phase lead and mission.
Yeah, this is Mission. On behalf of Brian and me and the...
And joining us now is John Grunsfeld. Dr. Grunsfeld is a physicist in charge of all of science projects at NASA. He's also a former astronaut who flew on 5 shuttle missions and made especially out of spacewalks to refurbish the Hubble on 3 of those. And Dr. Grunsfeld is here with us now. And here's your honorary bottle of peanuts. Good luck, peanuts, for today's mission.
Yep, we're going to need these.
Yes, we will. So let's talk a little bit about this mission and how does going to Mars again, why is that so important to NASA, and why do we need to go back to Mars?
Well, Mars has a very special place in our solar system as the closest analog to Earth. And so there's a couple of different ways. One is the science answer, which is because it's close analog, especially going to Gale Crater, we can understand the history of Mars, and I'm sure John Grotzinger has told us all about this, as if we were going down into the Grand Canyon and measuring, the geologic history. So we can compare the Earth to Mars at the same time as the solar system formed, as these planets formed. And of course, to answer the really important question, which is a human question, are we alone in the universe? And so, although the Curiosity rover isn't designed to look for life, it's to look for signs of past habitability, and this will give us that answer. But it's one other thing is, we live in a solar system of riches. Jupiter, Saturn, the moons, the Earth, of course. Mars is the only place where someday, humans could live on a planet kind of like Earth. And so it gives us the vision of what might be the future.
So it's putting all the pieces together, and this is one of those pieces to build ourselves up to the next one, the bigger one.
That's right, the bigger one.
So we're going to take a break and tell you a little bit about the peanuts. And I don't know if you've seen what's going on in our control room here as well as in the MSA.
Well,
but
I hear lots of munching.
There's a lot of munching, and we're going to let you partake here.
Thank you.
This is a tradition here at JPL. It goes way back to the Ranger days. And what had happened was we had 6 missions. They all failed, but we kept on trying and kept on trying. And then Ranger 7 did it. It was able to achieve what it was meant to do at the moon. And somebody was eating peanuts at that time. And somebody figured those must be good luck. So since then, on every mission, we dare mighty things by munching peanuts.
Yep. And of course, Ranger 7 set us up for Neil Armstrong and Buzz Aldrin.
That's right.
To land on the moon.
That's right.
In the same way, I think Curiosity is going to set us up for a time where women and men in the not too distant future will land on the surface of Mars, and they'll be astrobiologists and geologists, and they'll be able to build on Curiosity's mission.
And you are a physicist, so what are you most looking forward to that Curiosity will discover?
The lessons from Hubble are that when Curiosity is roving and sending the data back to scientists on Earth, the biggest discovery is probably not going to be the one that is, some particular molecule that we're looking for in the rocks or a particular mineral. It's going to be something that nobody's ever thought of. It's going to be the real discovery space. And that's what I think Curiosity will give us.
So you don't even know what it might be.
Nobody knows what it'll be. And Mars has a history of surprising us that way.
All right. Well, thank you for joining us.
Thank
I'll
you.
let you go back in the control room.
Okay.
This
Go
is a big
Curiosity.
night. Go Curiosity.
Thank you.
And if you just joined us late, you're watching live coverage of the landing of the Curiosity rover on Mars from NASA's Jet Propulsion Laboratory in Pasadena, California. JPL is managed by the California Institute of Technology on behalf of NASA, and we will be back in a moment with Rob Manning, but we'll take a break first.
Okay, we're only 22 minutes to entry. Things are continuing to go well. You might have seen here that we've passed out the traditional peanuts. We need all the good luck we can get here. But things are continuing to look very good. We're right where we expect to be, and everything is going fine on the spacecraft. Curiosity is reporting things are going fine. Right now we're standing by for Odyssey to tell us that they'll be around to broadcast what's going on for us during EDL, to relay that telemetry we get from Curiosity. So we're waiting for them to come back to Earth, to talking to Earth, and hopefully we'll be able to see all the way to the ground and past with Odyssey.
12 minutes. Now would have been better. Are you still this guy? Is it down the We're going to do nicknames for you? I'll never live that one. No? We might have made somebody
We are 3 minutes past the top of the hour, and with us right now is Rob Manning. He is the chief engineer for the entire Mars Science Laboratory mission. And everybody is still very conscious of this communications issue, whether or not we will know for sure if Curiosity landed okay, and we'll know it.
Yeah. Yes, well, we do have a fantastic, excuse me, I'm just finishing the peanuts.
He's eating peanuts. Sorry.
We have a fantastic array. We've got three spacecraft. Odyssey spacecraft flying overhead, Mars Reconnaissance Orbiter is flying overhead. We even have Mars Express, European's Mars Express overhead, as well as these tones that we're sending back to Earth directly. So I think we have a video.
We have a video, and maybe you can kind of walk people through it to understand this. Okay.
Yeah. Okay, so as MSL approaches the atmosphere, we'll first have a straight shot of Earth looking backwards from behind us. Earth is to the left of that view. The great thing is, as it's coming in, we have two orbiters. You'll see them come into view in just a second. First, MRO from the south working their way north, and this is about the time that MRO is recording information that MSL is sending out to the world. At the same time, Odyssey, which is coming in from the top part of the view, is listening to what MSL is doing. And right now, MSL is sending information through Odyssey, and Odyssey is repeating that information straight back to Earth. And that's what we're seeing in this room tonight.
And you see where Odyssey is, where it is on the horizon, and how far it is. And that's one of the reasons why we have a very narrow window when we can...
This is a pretty tricky dance. It's been very well choreographed. People like Brian Schratz have done a fantastic job of making sure that all the coordination is happening. But it's it's easy for this not to work. One of the problems is the antenna is moving around. It gets blocked by equipment as it falls apart. The vehicle comes apart. It is something that you can't rely on in a guaranteed sort of way. So if the signal stops, we stop being signaled, it doesn't necessarily mean that there's anything wrong.
So we will know fairly soon in the next several minutes whether or not Odyssey's move did indeed work, and that it will be in position for us to be able to hear.
That's right. Odyssey had to get into position. It had to stow its antenna, the one that goes back to Earth, turn the vehicle so it's pointing at our vehicle, and then restow the antenna and start transmitting. So what it hears from the rover, it can repeat back to Earth. But that process means that it had to stop talking to the Deep Space Network for a while while it was doing that. And that's happening right about now.
So the point is that people shouldn't get too excited if we don't hear from the rover
That's
at landing?
right. We've had problems with communications all along. I mean, in fact, one of the reasons we put so much effort into this is so that if we do have a real problem, we can use this information to deduce what may have gone wrong. And so that's why this information is so essential. But if we don't get it and we land safely, that's still okay too, even though it's just nerve-wracking.
Okay, so Rob, we're going to keep you here while we go through entry, descent, and landing. He'll be there to give us his wise knowledge in all of this. But meantime, let's go back into the MSA and get ready for entry, descent, and landing.
Things are looking pretty good right now. I'm getting a report right now from Odyssey that they're in position. They're going to be there for us for EDL. So they have reacquired to the Earth, and we're good to go. So we will have coverage throughout EDL, through a little bit from about a minute and a half after entry, through touchdown, and then some. So hopefully we'll see all the way to the bottom and see a successful landing. Okay. The EDL activity lead is about to narrate what's going on in the spacecraft. We're entering the EDL prep anchor. That's a EDL flight software mode, so let's listen in.
You can see that the nav filter is dropping to the correct state. IBP has stopped, and the EDL prep anchor is complete. Okay, copy that.
Right done.
So we're about 3 minutes from the HR spent anchor action starting.
The activity lead has told us that we've turned off the attitude control system, the cruise attitude control system. We don't need it anymore. We're standing by for heat rejection system vent. That's the coolant that's been keeping us cool through all of cruise. We'll vent that ahead of cutting the cruise stage. So we're coming up on cruise stage separation.
Go ahead, Phase.
Anytime you guys want to shoot me any results from the sims to me via email, I guess is the way we're going to go now, because the screens are going to transition into having your beautiful faces on it instead of your estimates from the
flight EDL. The EDL HR spent actions have begun. Roger.
Phase, we should have our EDL viz on there when we get UHF data.
Roger. I'm still open for receiving best estimates as they come in on the landing location off of the time point correlation.
Copy, I understand, and we are on it. You will get it in the usual communication window.
Flight EDL. The expected warnings for the Electra hail mode are received. Copy.
The EDL team is running some final simulations to show where we think we're going to end up based on the latest navigation data. Things continue to look good. It puts us right in the middle of the ellipse.
Okay, flight, we can confirm the BCB actions have been commanded, and through EHA we can confirm that the discharge beds are now in manual discharge.
The vehicle's power changes in preparation for cruise stage separation. It's going to cut loose the cruise stage and all that solar array that's been powering us through all of cruise.
Pyro firing cards are now powered on.
Go ahead, EDL com.
So we're ready to switch the displays over to the 1010 marker, which will show EDL data manual tones. You ready?
Standby 1. Yes, we are ready.
Copy that.
All right. And we can confirm through EHA now that the BCBs are in manual charge mode.
Copy. BCBs in manual charge.
We've also completed enabling the pyros commands. We are in the process of powering off the cruise stage hardware. And we can verify through telemetry that the cruise stage harbor is powering off.
Okay, the cruise stage is turned off.
Flight Pyrobus is armed
Copy. Thank you, Pyro.
and enabled.
Pyroelectronics that are used to activate many of the devices that are going to be used to cut the cruise stage, and a lot of the separation events during EDL have been armed. Nav is confirming that we are starting venting. HRS vent has started.
And flight EDL, we're firing our first pyros to vent the HRS system. The medley RTDP warnings are expected.
The navigation team can see that the fluid coming out of that heat rejection system is actually pushing the vehicle a little bit, as expected. So we can confirm that the vent is actually happening.
RCCOM, RC Mission Manager on EDL Ops.
EDL Com, this is Dynamics on EDL Ops.
Go ahead, Dynamics.
Is our display configured correctly for you in the MSA?
Affirmative. I see it. Waiting for X-band tones. Very nice picture. And we're expecting tone start at 5:13:17 UTC.
Copy.
We're under 2 minutes from cruise stage separation.
RCCOM, RC Mission Manager on EDL Ops.
Odyssey Mission Manager, this is EDL Ops on EDL Ops.
Odyssey has completed its salute of the EDL Com attitude. All systems are nominal. Odyssey is go for EDL Com support.
Great to hear from you. Thank you very much.
We have a cruise stage step about to happen.
For all of EDL, so we will have their coverage. Things are looking good for them, and they're looking good for us. We're about 1 minute to cruise stage separation.
Tones.
We're seeing the transition to tones now. The system should be configured shortly. And we're seeing carrier only.
The vehicle's changing to tones at this time. So we're switching from telemetry, we've lost telemetry, and we're going to move to just tones.
EDA acquisition. And we're seeing heartbeat.
We are receiving heartbeat tones at this time.
Affirmative, we're seeing the expected 2 seconds of heartbeat, followed by the 10-second carrier pulse.
NAV can see something that could be consistent with cruise stage separation in the Doppler.
And we're showing a good strong signal, higher than expected carrier power, and continuing seeing heartbeats. EDL Com tones look good.
We are receiving heartbeat tones at this time. Things are looking good. We see that we are priming the entry RCS thrusters. Cruise stage separation. In about 1 minute, Curiosity's EDL software will wake up and begin final preparations for entry. The first action it'll take is to fire some warm-up pulses to get the entry RCS thrusters going. The pulses will ensure the spacecraft will get the thrust that we want when it's counting on it.
We did see the heartbeat signal drop low for a second as the signal passed by the donut of the cruise stage.
We are seeing RCS warm up.
Flight, this is enough.
Yeah, flight, go ahead.
Could you check with the ACE whether we should be seeing one-way data from the station?
Ace, did you copy?
Curiosity is reporting that it is spinning down and turning to entry.
Flight HS, we've been one way for a while now.
Roger that.
But currently we're just seeing the tones, obviously. Roger.
Vehicle is reporting that it has completed its turn to entry and spin down, and it has separated the cruise balance mass devices. At this time, the vehicle is just sending heartbeat tones, just as we expect. It should be quiet for the next several minutes, hopefully. We are about 7 minutes to entry. At this time, Mars is actually pulling Curiosity in, and we're speeding up. We should be traveling around 5.4 kilometers per second on our way to about 5.9.
So, Rob, what are your thoughts at this point?
Well, I'm very
variation
excited.
in the pattern, antenna pattern is
This is
reflected
the
in the variation.
this is the part that really is entry. This is where we're getting to the top of the atmosphere. The great thing is that the propulsion system's shown to be working. We're turning the vehicle. It looks like the vehicle is going to be doing its entry job very well, and I'm very excited about that. Everything is going very well.
Right.
So make sure everyone keeps their eyes on the television, because we might actually get some pictures if all goes well. And we might be murky and covered with dust when we first land, but we might get some pictures today.
Wow, at landing.
Just a few minutes after landing.
Excellent. Okay, we're standing by.
Thank you.
We're just under 6 minutes to entry. We're continuing to wait for entry interface. The spacecraft is continuing to send heartbeat tones, telling us that everything is okay and there's nothing significant to report. This is as expected. It should be quiet for a little while, at least. We're now 5 minutes to entry. Continuing to receive heartbeat tones. Everything is good. At this time, Curiosity should be up to about 5.5 kilometers per second.
So what's taking place now?
So right now the vehicle is flying through space. It's actually in deep space still. In fact, not until after we hit the entry point will we actually begin to feel the force of the atmosphere gradually building on that heat shield. So really it's still a spacecraft. It hasn't actually become an aircraft. But we've checked out its rockets. It's actually used to turn the vehicle. It's turned to the right attitude, and that means it's ready to go. And as soon as we start feeling the atmosphere, it'll start doing its role to get to the turn as part of the guidance that it does. It starts off with a right bank, and eventually will make a left bank, and then make another right bank as it makes its way to the landing site.
So it's a capsule right now.
It's a
headed
capsule.
in.
It's just a bare capsule. Nothing looking out. Just the radios is the only thing that's sticking out, and that's what we're getting. We're getting tones from that vehicle right this second.
Okay.
Now we're not getting Odyssey data yet. That doesn't happen until a little while later.
After parachute.
Actually, just after entry, about the time before parachute, just before parachute opens up.
Okay.
EDL phase dynamics.
Did that work out?
Go ahead, dynamics.
Just FYI, OD227 run out looks like missed distance of 232 meters. Over.
232 meters?
That's correct. Less than the divert.
Roger.
We can expect a brief signal dropout when we switch to the TLGA.
We're at 3 minutes to entry. At this time, MRO should begin picking us up. But remember, we won't get that data for a while. It's got to store it and then send it back down here for us to decode. We're still seeing heartbeat tones. Everything looks good. Spacecraft should be up to 5.6 kilometers per second.
Those two are trusting the hardware.
We have 228. It's right on top of 227. See that? No.
2 minutes to entry.
The EDL team is reporting that the latest runouts, which is using the latest nav, our best guess of where we are, show us that the best guess of our landing target location is about 232 meters from the landing target. So, looking good so far. We're continuing to receive heartbeat tones. Everything looks good. We're about 90 seconds from entry.
Flight dynamics, EDL phase.
Go ahead, phase.
That last solution was with 227 or OD228?
That is OD227.
Thank you. You guys have now OD228 in your possession?
There will be no 228 for us, phase.
That's just fine because the difference is
1 minute to entry.
Within spitting distance.
Affirmative.
The vehicle will switch antennas shortly. We'll have a short dropout when that occurs in the tones. It's switching to a tilted antenna that will be used through entry.
Right,
30 seconds to entry.
As we come up on entry, we'll expect a 2 to 3 second outage in the X-band signal as we switch from the ELGA to the TLGA.
We're switching to the TLGA, signals dropped, and it's...
We just saw the signal drop. That indicates we changed antennas.
We're seeing heartbeat tones again after the switch. Things are looking good. We got tones back again. Coming up on entry. Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. It'll use that for all the maneuvering in the atmosphere we're about to do.
Back to heartbeat tones.
We are standing by for guided start and the start of guided entry.
Nav can see the entry in the atmosphere in the Doppler.
We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. It is starting its first bank reversal. First bank reversal complete. We have seen peak deceleration. We've passed through peak heating and peak deceleration. It is reporting that we are seeing Gs on the order of 11 to 12 Earth Gs.
Flight GDSA.
GDSA flight go.
We are processing data from Odyssey.
Bank reversal 2 is starting. We are now getting telemetry from Odyssey.
All right.
Bank reversal 2 complete.
Copy. Bank reversal 2 complete.
Thanks.
Standby flight. We have a connection, but we actually do not have any data yet.
Copy.
We can expect some intermittent contact at this time as the signal increases to respectable levels.
There we go. We are now seeing
And we have
our
our CDPs.
Okay, copy.
And visualization is updated.
We have entered heading alignment.
There it goes.
At this time, Curiosity is no longer trying to control how far it's flying downrange and is just heading directly for the target.
End of range control, air used minus 1.2 kilometers.
Minus 1.2.
1.2.
The EL team is reporting that that things look pretty good at the end of range control. We have converged a lot of the error, and we should be heading toward the target.
Flight EDL, TDS warning is okay.
Copy.
Power on.
We are seeing a tone from
the 1 gigahertz.
indicating that we have seen heating on the heat shield through the Medley instrument. Everything looks fine. This is as expected. During the setting alignment phase, we're flying almost horizontally like a plane. We're going about Mach 2.4 at an altitude of 17 kilometers or so.
Way better.
Vehicle's reporting heartbeat tones again, indicating that everything is fine during heading alignments. We are standing by for straighten up and fly right and parachute deploy. Vehicle's continuing to decelerate. We're down to about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7. We're at 15 kilometers altitude.
We've begun entry balance mass jettison. The predicted mid
downrange
is 1.597 kilometers.
EDL Ops, Odyssey Systems on EDL Ops.
Parachute deploy.
Parachute.
Thrusters have been re-enabled. We will control our attitude on shoot. We are decelerating.
Risk mode under
About 10 kilometers
parachute
decelerating
are 20
and
to
descending.
30
We are at 150 meters per second.
Dynamics phase. Come back again with risk mode dynamics.
Risk mode is nominal.
We are 9 kilometers and descending.
active.
Valid range.
Net filter converged with a velocity correction of 0.7 meters a second.
We've acquired the ground with the radar.
An altitude of 8 kilometers.
Heat shield has separated. We've found the ground.
Expand tones due to Earth occultation as expected.
We're standing by to prime the Emily engines in preparation for powered flight. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending.
Flight EDL, we got some Tweedo warnings. It is in battle short mode, so it should power through them.
Direct to Earth communications at this time. We may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters, vertical velocity of minus 82.8
We are priming
meters per second.
start enabled, standing by for back shell separation.
Signal to Odyssey is still strong.
We are in powered flight. We're at an altitude of 1 kilometer descending, about 70 meters per second.
Signal to Odyssey remains
down to 50 meters per second. 500 meters in altitude. Standing by for sky crane.
Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for sky crane. Down to 10 meters per second. 40 meters altitude. Sky crane has started. Descending at about 0.75 meters per second as expected. Expecting bridle cut shortly.
Signal to Odyssey remains strong.
Tango Delta nominal.
Yeah. EDLCOM configured.
Rim stable.
UHF telemetry.
Rim stable.
UHF is good.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us. At this time, flyaway should be complete. Descent stage is at a safe distance. We are continuing to receive telemetry from Curiosity. We're safe.
Getting data from the surface of Mars.
ASCAM sequence is kicked off, waiting for images.
Heads up, folks.
EDL ops, the signal to Odyssey remains strong.
Flight EDL images are starting to come down.
We're beginning to get images
we got
from
images
Odyssey.
coming down, folks.
EDLCOM configures stand by for images.
Reader has thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey is nice and high in the sky. At this time, we're standing by for images.
Thumbnails are complete.
We got thumbnails.
Full image complete. Full image complete. It's the wheel! It's the wheel!
There we go. We can see a wheel image. We are wheels down on Mars.
Oh my God.
We'll do a proper hug on the other side.
Keep watching, guys. Keep watching the screen. There's more stuff. Any minute now. No. 2:56.
Okay, okay. So here we are. We're going to start. Go ahead.
Okay.
So we have landed out at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail. The front, a rear has-cam image. You can see the shadow there. I'm not sure exactly which our orientation is of the vehicle, but we're looking through it. Now, I think in just a few minutes we might get even a larger 256 frame pixel image of that same end. So we're looking at the shadow. See, the horizon is actually in the distance. You can't really tell that. So we're looking actually at the shadow of this late afternoon sun.
So these are the rear has cams.
These are the rear has cams.
And it
so
does have a dust cover on it.
It does have a dust cover, but it's the dust. The cover is a problem. It's the fact there's dust in the air because we've just blown dust all over the place with our descent engines.
Fantastic. So there could be more.
There could be more. If we wait, we might get. Oh yes!
Ah!
This is the high res. This is the 256 by 256 image. This is a higher resolution. You're seeing dust particles on the window. You can see the horizon there in the background, and there is the wheel of the rover safely on the surface of Mars. I can't believe it. This is unbelievable. We might get another one of these, and if we're lucky, before Odyssey goes away, we'll get 2 more of these same engines going the other side of the vehicle, and also probably dusty. This is amazing.
So that is one of Curiosity's rover wheels
exactly.
on the surface of Mars.
Yes. Whoa! Wow! Now we have another. There's another image coming down. This is a view looking the other direction. It's still being processed. You'll see it in just a second here. This is another thumbnail image.
Is that a shadow?
That's the shadow
of the rover.
Curiosity rover on the surface of Mars. Thank you.
The Odyssey transmission is about to end. It's about to set below the peak of Mount Sharp very shortly. So this is about all the data we're going to get, but things look great.
Congratulations.
Thank you very much. Thank you.
anybody in the MSA is listening, you should check out our target location on this current fly-through. If anyone in the MSA is online, you should watch this fly-through.
All right, well, we are very pleased now to have with us the Administrator of NASA, Charlie Bolden, Welcome and congratulations. We're on Mars
Thank
again.
you. We're on Mars again, and I'll tell you, it's just absolutely incredible. It doesn't get any better than this.
What was it like for you? Were you on pins and needles just as much as we were?
I was a basket case in there. I was really on pins and needles, and you know, it was the irony was we were sitting there saying we know we're on the ground, we just don't know what kind of shape we're in. So to hear the calls come saying everything was all right, it was great.
And how about seeing the pictures?
This is, that's incredible, and it's a huge day for the nation. It's a huge day for all of our partners that have something on Curiosity, and it's a huge day for the American people. So as I told people as we went around earlier tonight, everybody in the morning should be sticking their chest out saying, "That's my rover on Mars," because it belongs to all of us.
Well, that's what I'll be doing tomorrow morning.
Well, you should do that. You should do that. Yeah,
well,
I tell you.
thank you so much for dropping by.
Thank you.
I know that
Thank you
you are
very
getting
much.
ready for a news conference.
We are.
We are so glad and so pleased you could join us.
Well, thank you very much, and thanks for carrying us through this whole thing and making the public able to see what's going on here. I've been watching you, and it's been great.
It's a good day.
It is a great day.
In a moment, we will have Dr. Charles Bolden, but let's go back to the room for a bit.
Dynamics, this is Phase.
Okay, folks, we're on page 91 in the procedure.
Roger. Hold everybody there so we get a chance to get over it. We'll turn the together.
All right, it is my distinct pleasure to welcome with us President Obama's science advisor, John Bolden. Thanks for joining us. It was such a pleasure to have you join us for this big landing.
Well, I'm very happy to be here tonight. Very happy to have seen this incredible accomplishment with this Mars landing.
What does this landing mean for the nation?
Well, it's an enormous step forward in planetary exploration. Nobody has ever done anything like this. We are actually the only country that has landed surface landers on any other planet. But this lander is vastly bigger, vastly more capable, much more complicated to bring in. Many new technologies had to work in perfect succession and perfect synchronization for this to happen. It was an incredible performance by the Jet Propulsion Lab, by NASA, by the teams around the country who had contributed to this, and indeed partners from around the world.
So what does this mean? What future implications could we be seeing in this now that we've landed on Mars?
Well, this is by far the most capable device, set of instruments we've put up there for determining whether Mars ever could have supported life. And of course, the question of whether there was ever life on Mars is an enormously important scientific question, almost a philosophical question, relating to our place in the solar system and our place in the universe. So we stand to learn a tremendous amount from this Curiosity Mars Science Laboratory. It really is a portable science laboratory. It's going to do incredible things.
And with all science experiments, with all science, when you get some answers, it just leads to more questions.
It leads to more questions, and it's always the way of science, but it leads to ever more interesting questions and a larger body of knowledge from which those questions emerge. And we know that the space program has for decades been very important to the United States. It's been important economically. It's a driver of innovation with widespread applications, but it's also a source of inspiration to the next generation of young people who are going to become the scientists and the engineers and the technicians that ultimately will land people on Mars.
Right. These are the footsteps leading to that.
Absolutely.
Well, Dr.
It's going to
Bolden,
be crucial.
Thank you so much for joining us. I know everyone's excited. There will be a news conference at about 11:15 our time, Pacific time, and it's a good day, and thank you for being with us.
It's a great day. Thank you very much.
All right.
Just a second.
Thank you.
Thank you so much.
Roger, the Dynamics, we're on MSL Ops.
Okay, Dynamics. Flight director's ready to copy.
We have a touchdown time of 10:14:39, which is in PDT. Sorry, I apologize for that. UTC is required in the poll, so you can do the conversion.
Stand by one. Got a little laughter on that.
Let's see, step 730.013. So we have a touchdown velocity vertical of negative 0.607398 meters per second. Step 14, touchdown velocity horizontal 0.044365 meters per second. Expected fuel remaining at flyaway. Sorry, Ben Toma, we have 140.6 kilograms. For step 16, we will need photo confirmation of descent stage location. Step 17, offset between rover z-axis and gravity vector of 4.37 degrees.
Yes.
And finally, in step 18, we have our navigated lat-lon calculation, which is negative 4.591817 degrees. Longitude of 137.440247 degrees, and that gives us a navigated range to target of 2.279.
All right, well, they are in the midst of the post-landing poll. Let's take a moment now to introduce you to JPL Director Dr. Charles Bolden. Dr. Bolden, you have experienced Mars landings before. They are all nail-biters, but this one had to have been one of the toughest.
Yeah, absolutely. I mean, this was particularly so exciting, and things went so fast. But as I saw the parachute actually opened and was slowing down, I told Charlie Bolden, we're halfway there. And then it was just so exciting. You know, it's like a movie.
So how does it feel to be back on Mars?
It feels fantastic. You know, at 9:15 earlier today, I went out, looked at Mars, which was setting. And I said, in an hour and 15 minutes, it's going to be different. You know, there is going to be the pre-Curiosity landing and the post-Curiosity landing. And this is exciting on behalf of all the world, NASA, the public. This is one of the most exciting things I've seen.
Absolutely. And what do you look forward to now?
Well, we're looking forward, now that we did this one, we're looking forward for the discoveries that this mission will make. We're looking forward for going again to Mars and continuing to go to Mars, going to Europa, go to all the planet. This is the mighty things that our agency is doing for the American people.
A wonderful, mighty thing.
Absolutely.
Dr. Bolden, thank you
you
for joining us. I'm going to let you go so you can go to your news conference. Again, we are expecting a news conference at about 11:15 Pacific time. And for those of you who have been trying to go to the NASA websites, we do understand that all of them have gone down because all of you have been going to them, looking for the images and looking for this coverage. There is one available. We have a super of the one remaining website that is available. Let me read that to you. It's mars.jpl.nasa.gov/MSL/raw. This is where you can see the images that just came back from Mars. Let's go back to the room.
We won't get the sequence picked up here now.
And Flight Systems, we do not have the expected value. We have it as a value of 1, which is autonomous.
And Flight EDL, the sequence was changed late to execute a little later, so we missed that.
Roger that. steps 27 through 33.
Copy that. Power subsystem is currently nominal for step 27. For step 28, the channel power 4007 last data point reads 1.56 amps. For step 29, buzz voltage last data point was 32.18 volts, roughly 93% of state of charge. For step 30, battery 2 current, last data point read is 1.57 amps. Step 31, power 4018, voltage reads 32.2 volts. Step 32, Pyro 0120 reads 2491 ohms. Step 33, Pyro 1120 reads 259 ohms.
Roger, copy power. And thermal, can you please report on steps 19 through 26?
Roger that, flight. For therm channel 0768, the REPA gas pressure, we have a pressure of 109.6 psia. For therm 0833, it's invalid data because it's the liquid channel on RPM B. For therm 2804, RTG1, we have a temperature of 142.1 C. For therm 2813, RTG2, we have a temperature of 127.6 C. For therm...
Just to confirm, 127.6, was that right?
Copy that. 127.6.
Well, we have good news. We are told that the website www.nasa.gov does have its images back, so several of the websites crashed because of all the people who are trying to see these first images from Mars from Curiosity. So once again, look at the screen. We do have the NASA.gov website back and also the JPL RAW website back up. Meantime, with me now is Lori Garver back again in the seat. So how's it feel for you? You went through the whole experience.
Well, we all did, right? We were joking that maybe Michael Phelps was the only one who could actually hold his breath that entire time. But there isn't anything more exciting. It's one of the reasons we do it. And I just congratulate the team. It's an amazing thing to have those pictures right now.
Could you believe that? To have them so soon and what you could see them in them.
I did not expect them to be as clear and good, to be able to see the definition of that. And to recognize what the team went through and the challenges that they have faced to do this and how successful they've been just so far. Let the science begin, right?
Let the science begin. Well, we do have a news conference in just a short time. Deputy Administrator Lori Garver, thank you for joining us, and it's a good day.
It is a great day for America, for the world,
Absolutely.
for our future, so thanks.
All right, thanks for being here. And we'll go back to the room into the MSA.
730.002, can confirm the EVR DMCA received through CLF. I can confirm that MCFSW was receiving good DIMU packets via the MCFSW status, which read hex 1100. And also the absence of any warning EVRs indicating a problem with the DIMU. So as far as we can tell, DMCA was executing flyaway nominally.
Okay, copy that.
And you're expected to
Well, the flight team is almost done. They are in the post-landing pole, and this is to say that Curiosity is safely on the surface of Mars, and the post-landing pole is kind of a symbolic handing over the keys of the rover to the surface operations team. They are operating in another room from here, just a short distance away from the MSA, the cruise MSA, and that's where the TV crew and I will be heading for the 12:30 a.m. show, or the commentary for the next Mars Odyssey downlink, which will have possibly even more pictures. Coming up next, the post-EDL news briefing at 11:15 Pacific time, just a short time away. This has been live coverage of the landing of Curiosity from NASA's Jet Propulsion Laboratory in Pasadena, California. JPL is managed by the California Institute of Technology on behalf of NASA. And again, you can continue to watch coverage. You can also see the images at www.nasa.gov. Also our raw images. Meantime, I'm Gay Yee Hell. Thanks for watching, and we're on Mars again.
So Mike, packing it up, moving. Great job, by the way. Thank you. Everything after the surface transition was nominal from the place up to the wheel. You have pillows? You have pillows over there. You have cushion there. Excuse me? I'm gonna go join my team. Thank you. Thank you.
A seat. Live from NASA's Jet Propulsion Laboratory in Pasadena, California, and on Mars, I want to present to you the team that has brought us back to Mars tonight. Come on, guys. I see him. There they are. Woo! There we go. Over here, John. All right, let's give them one more round of applause now that we've got them all up here. Thank you very much.
Well, good evening, everybody, and welcome to Mars. I mean, to NASA. About an hour and a half ago, I went outside and looked toward the west, and I saw Mars there, and I said, in an hour and a half, you are going to have a visitor. And the planet smiled, and I knew that we were going to have good luck. So with this, I want to introduce you our fearless leader, Charlie Bolden.
Boy, I'll tell you, Charles, thanks very much. First of all, just let me say thanks very much to the entire team and all the teams not here. Some of the teams in places like Canberra, Australia, and up in Goldstone, because the Deep Space Network was what made it possible for us to be getting all the data and everything. So, you know, but today, right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars. Curiosity, the most sophisticated rover ever built, is now on the surface of the red planet, where it will seek to answer age-old questions about whether life ever existed there on Mars, or if the planet can sustain life in the future. This is an amazing achievement, made possible by a team of scientists and engineers from around the world, and led by the extraordinary men and women of NASA and our Jet Propulsion Laboratory. Nothing in robotic planetary exploration is harder, more technically challenging, or as risky as landing on the surface of Mars. And I know most of you are saying, how can he be saying that? It just looks so easy. Trust me. Historically, counting all the missions by all countries, the odds of success are about 40%. The recent U.S. record is better, with now 6 successful missions, including now 4 landings. And I'm going to stray from my script here for a moment, which is always dangerous. But tonight, and I'm probably not going to include all the countries, but tonight there are at least 4 countries, and I won't name them, who are on Mars. And they're on Mars because they went with the United States. So I know this may sound a little strange in this international environment, but I want everyone to understand what I say and what I mean when I say, you know, our leadership is going to make this world better. Tonight, As incredible as our feat was tonight, we just succeeded one more time in raising the bar even higher. New technologies never invented or attempted before were created for this incredible journey. Curiosity's final descent was dubbed 7 Minutes of Terror because in its 7-minute trip to the surface, it had to slow down from 13,000 miles an hour to 0. And I think you've heard this before. That's like driving 65 miles an hour on a freeway and coming to a complete stop in about 2.1 seconds. Hundreds of other things had to go just right, including a parachute slowdown at supersonic speed, 8 rocket engines to power a final descent and final soft landing by a new sky crane landing system. Curiosity will spend the next 2 years seeking answers to one of humanity's oldest questions, as it investigates whether conditions have favored development of microbial life on the red planet. President Obama has laid out a bold vision for sending humans to Mars, and today's landing marks a significant step toward achieving this goal. And now it's my pleasure to introduce to you a very dear friend of mine. He is the President's Science Advisor, the Director of the Office of Science and Technology Policy, and a guy who was sweating through this. And as he told me a little while ago, he thought he was going to throw up at one point. And he's probably mad because I told you that, but my friend, Dr. John Holdren.
I wanted to start by saying thank you for sharing that, Charlie. Well, today on Mars, history was made on Earth. The successful landing of Curiosity, which is, as Charlie has said, the most sophisticated roving laboratory ever sent to another planet, marks what is really an unprecedented technological tour de force. It will stand as an American point of pride far into the future. It's also just the latest example of a long-standing truth about the United States, that even the longest of odds are no match for America's unique blend of technical acumen and gutsy determination. And that's certainly for all of the folks at JPL, at Caltech, at NASA, and our partners whose instruments, as Charlie has pointed out, were on this lander. Big thanks are due to all of them. Our continued preeminence and progress in space and here on Earth in other domains such as biomedicine and healthcare, clean energy, national security, advanced manufacturing, all of this depends on our continuing commitment to science, technology, and innovation, and the passion for adventure that has driven us to explore new worlds. By sustaining our investments in basic research and exploration, we ensure that America will remain at the forefront of the scientific frontier. So I really want to personally congratulate, on behalf of myself, but also on behalf of my boss, President Obama, the team here at JPL at NASA and around the country that contributed to this spectacular achievement. I can only imagine what incredible data and new understandings are going to be uncovered in the coming days, months, and years because of this success. Landing the Mars Science Laboratory rover, Curiosity, on the surface of the red planet was by any measure the most challenging mission ever attempted in the history of robotic planetary exploration. And if anybody has been harboring doubts about the status of U.S. leadership in space, well, there's a 1-ton automobile-sized piece of American ingenuity on the, that is... And it's sitting on the surface of Mars right now, and it should certainly put any such doubts to rest. President Obama has challenged America, as Administrator Bolden just said, to send humans to Mars in the 2030s. And Curiosity is going to provide critical information about the red planet and what our astronauts will find once they arrive. The administration is committed to a vibrant and coordinated strategy of Mars exploration and planetary exploration more generally, and continuing America's leadership here on Earth and throughout the solar system. So congratulations again, and long live American curiosity. Thank you.
Let me thank all of you one more time. John Holden and I, unfortunately, have got to go boogie to go somewhere else. We're going to leave you in the very erstwhile hands of Charles Alachi and the technical team, and they've got a little bit more detailed stuff to tell you. So have a great night, and congratulations to all of you again.
Okay, guys, before we start, we have a new picture of Mars. Come in.
Here comes the rest of the EDL team. The Mars Curiosity team entering right now. They are quite happy.
So what is the order that you are doing?
We're going to have you sit back down and...
But somebody put this...